Continuing our discussion about wave and oscillatory motion, we have two definitions that we're going to look at, both of which you've probably heard before, but not necessarily in a physics point of view. So we'll define them from a physics point of view. We are talking about periodic motion for this type of motion. Now, periodic motion is motion that repeats itself at regular time intervals. So examples of periodic motion, the Earth going about the sun or the moon going about the Earth. Periodic motion, a child on a swing, or any type of a pendulum, rocking back and forth. The train car, the clattering clack, clack, clack of the train as it moves over a track. Or the bumps you hear as you're driving over a highway, especially the metal grates over a long bridge, where you hear the hum, bump, hum, bump, hum, bump. Any type of motion that repeats itself at regular intervals is called periodic motion. Now, oscillatory motion is often periodic motion, right? Oscillatory motion is motion that's going back and forth like a child on a swing. But periodic motion is not necessarily oscillatory motion. For example, think of a roller coaster. A roller coaster starts off, goes down a bunch of tracks, does some loop-de-loops, and then comes back up, and then repeats that process again, and that occurs at regular intervals. But that is not oscillatory. It's not back and forth between 2 points. The moon going around the Earth is not oscillatory per se, because it's not oscillating between 2 points. It's completing approximately a circle around the Earth. But it is periodic. Now, a period, we use a capital T to represent period, because period is a time. It's the time to complete one oscillation, right? And we're going to be looking at simple harmonic motion as periodic motion, the simplest version. So oscillations are periodic motion. So the time to complete one oscillation or event, right? The time to complete one time interval. How long does the moon take to go around the Earth? How long does it take the Earth to go around the sun? That is the period. How long does it take a child to swing from a back position forward and then back again? That's the period of motion. Time, it's a time, so the units are SI units of seconds. We don't use period very much, though. We tend to use frequency more often. Frequency is the number of events per unit time. So period is time per event. Frequency is events per time, so they're inverses of one another. So the number of events that occur in some unit of time, the unit of time typically, again, is the second. So how many events occur per second is defined as a unit, what's called a hertz. Hertz has 2 letters, capital H, lowercase z, to represent hertz. And you're familiar with this if you've ever listened to a radio station. If you tune into a radio station, say 101.5 or 107.9 or 90.3 megahertz in the FM band, that is light waves. It's a light wave that oscillates at 101.5 megahertz, or million times a second, or 90.9 megahertz, million times per second. So what you're telling your radio when you tune to a specific station is, I want you to amplify and decode the signal at this frequency. So frequency is given in units of hertz. Now, because they're inverses of one another, one is time per oscillation, the other is oscillations per unit time, or events per unit time, there's a very simple relationship connecting these two. The frequency is 1 over the period, or solving for period, the period is 1 over the frequency. So because of this simple relationship, hertz is just 1 over seconds. Again, there is no, it's events per unit time, but events isn't a unit. It's just number, it's a number. So hertz is 1 over seconds. So we're talking about both the period and the frequency of some event. If you know one, it's trivial to get to the other.